Hello and welcome to this Martindale webinar based around the topic of safe electrical working, focused on safe isolation and what you need to know. This presentation will take around 15 to 20 minutes and we will answer any questions that you have via email at the end of the session, and we will copy everybody in who has asked a question or has registered for this webinar. I hope you find this information very informative and useful. What we want to cover today on the agenda is obviously why electrical safety matters, the reasons behind it, changes to the new sentencing guidelines, who is responsible, and to point out who is the main duty of care and who should be responsible. There'll be a short 2.5-minute video of a topic around a real life incident that happened called Michael's story. If you can obviously just watch it, it brings it home about a real life incident that happened. Go through some of the legislations, GS 38, HSG 85, and some of the British standards that we have to manufacture to, and then choosing the right equipment, making sure that we have the right tools to be able to carry out our work and obviously do it safely. So if we move on to why electrical safety matters, there are roughly around about 1,000 serious accidents a year due to the contact obviously with electricity. I always say that I served my time as electrician on the 14th edition and we didn't have safe isolation in those days, but everybody or most people will have had an electric shock of some form. I will hold my hand up and say yes, I have, but I've just been one of the lucky ones. I'm still here obviously doing this presentation for you, but it just shows how many electrical incidents there are, and these are the ones that have actually only been reported. How many other situations go on where they haven't been reported? According to figures, 16% due to fatalities for accidents at work have been related to electricity, and that is 16% far too many in my eyes. And what you have to think about is that the consequences of people getting killed at work are not only devastating for that individual, but also it's obviously to do with family members, wives, brothers, sisters, daughters, sons, aunts and uncles, and it just keeps going on, as well as work colleagues. And a lot of work colleagues get affected if they've been in the same vicinity, if they've been working around them when something's happened, and also a bit of guilt comes on because in your own mind you start to think, what could I have done to try and stop this, or could I have done something that we obviously could have done differently? And because of this, when you listen to Michael's story a bit later in the video, the company that was involved in this was fined £300,000 for a death. If you look at the report from the HSE, and I've put some obviously comments up there from a northeast company for some burns, and you can see by the image they are severe burns, the company was fined £900,000. so the penalties that the HSE are bringing in now are much more tougher. They're trebling and potentially can be up to £10 million. So the new sentencing guidelines that came into effect in February 16 and November 2018 is the amount of fines for putting employees at risk, so not just for those accidents that have obviously occurred. Imprisonment for directors, managers, employees now, which is where it's slightly changed from, whereas before it would go to the top and the person in charge would be the one that would be obviously taking to court. A lot of the emphasis now is being put on the people actually carrying out the work to make sure they're doing their job properly and that they are actually competent to do that work. It's split down the different levels of where the responsibility lies. And as I said earlier, fines now exceeding £10 million for large companies, whereas you go back to 2007 and Michael's story, it was £300,000. And this is the HSE being a lot more stringent in what they're doing. So who is responsible? The first thing is that employers should not and cannot assume employees have the right equipment. There needs to be regular inspections of that equipment. you cannot just assume because he's got the equipment, he knows what to do with it. Management need to ensure that correct supervision and sort of procedures, method statements, being able to carry out the work safely and in accordance with what that company's doing. Now that also applies to any of the subcontractors who are working for those big companies. It's up to the company to make sure that their method statement relates and is followed by any person that is working on their behalf. And this is really key, is where you get the buy-in, is because, as I said in the first statement, you shouldn't assume that everybody obviously knows what they're doing, they've got the right equipment to do it, they've been trained how to do all of this. It's about crossing the T's and dotting the I's to make sure that everybody's aware and knows exactly what's in place and what everybody, procedural wise, should be doing and should be carrying out. So the Health and Safety at Work Act, there is a couple of sections which I just want to highlight, and this is all about making people aware that it's not the company that's making these rules. This is the Health and Safety at Work Act. It's legislation, all companies have to follow it, and these are the things which the HSE will look at if anything unfortunately did have to get hurt or was involved in an accident. It's sort of these three sections where we have in place. It's about the different levels of what the HSE will look for. It's about neglect from a corporate point of view. It's neglect from where you've got certain members of a business and that business is conducted and treated the same way as it would be as a corporate company. And you get to a certain level where if somebody unfortunately has been killed, of corporate manslaughter. And that's where the HSE and the police start to investigate, and that's where you then realise the seriousness of what this all means. And this is just trying to bring it home to everybody, is that yes, it's paperwork, it's exercises that we all have to go through, but it's about keeping people safe. It's about making sure at the end of the day everybody goes home safely. So carrying on from that, these are the two sections, section 37 and section 40. It's just showing you who is responsible, so duty holders. It's the different levels of management is where the HSE and the prosecutions will look at who has been responsible, and is also making sure that they have took enough duty of care to satisfy the safety of their workforce. I want to play this 2.5-3 minute video now on Michael's story. It's a real life story. It happened in 2007. It's been told by Louise Taggart, who is the sister of the brother of Michael, and just would like you to pay attention to it, and it brings it home about what everybody's trying to do, especially us at Martindale, about trying to make people safe and make sure they follow guidelines and make sure that everybody's working safely, that at the end of the day what happens to Louise and what happens to Michael doesn't happen to anybody else.
My brother Michael was an electrician. He was working with a colleague to install a security system, and he suffered a fatal electric shock. He'd cut a cable and he'd thrown it down to his colleague, and that cable was labelled not in use. Now he was stripping insulating material from the cable when he got to the live wire, and it was energised to mains voltage of 230 volts. The HSE inspector said if he'd been holding his snips by the insulated grips, there'd have been no effect. But the sparks, the other electricians that were working with him, said in practice when they were doing that job, they would have their thumb on the metal part of the snips to get the purchase necessary to get that insulating material off. He suffered a heart attack. And that came about because the most common reaction to electric shock is for muscles to contract. He was gripping his snips, the muscles in his hand contracted. He'd have desperately wanted to let go, but he couldn't. So that night I'd got home from work a bit later than normal. I was standing in the kitchen and I was making my dinner, And I'd just actually been thinking, when's that wee shite coming back to fix that socket for me? Just as I'd been thinking that, the phone went, and it was my mum to tell me that Michael had been in an accident in Dundee and that her and my dad were on their way to the hospital. So we jumped in our car, we set off on the 60-mile drive north, and when we got to the car park at Nine Wells Hospital in Dundee, I could see my mum and dad standing up at the door of accident and emergency, and I just knew that he was dead. They'd have been at his bedside otherwise. There were a series of safety failures that resulted in Michael's death. Lock-off tag-out devices weren't provided by Michael's employer, despite being referred to in the company's method statement. The company also didn't provide the testing equipment that they should have. They didn't keep the risk assessment live. So a risk assessment for low voltage electrical work is described by the mechanical project manager at the trial as being a living document, when in fact it was nothing of the sort. It was described by the HSE as being completely inadequate. Supervision was abysmal. The electrical supervisor was to tell the HSE inspectors when he was interviewed that he didn't regard it as part of his job to ensure that safe working practices were adhered to at all times. But the fact is that we're never going to know all of the answers to what led to Michael's death, because some of those answers could only be given by Michael himself. We don't know the process that Michael followed leading up to him cutting that cable. Did he test? We don't know. Or did he use a shortcut that it seems that a lot of sparks used then, and I think still used today, which is to cut through all three parts of a cable at the same time, and if it goes bang, it means it's live. I think the fact is that if management had been doing their job on that site, then if there were shortcuts, they wouldn't have been acceptable. The safe systems of work wouldn't have just existed on paper, they would actually have been put into practice. There would have been the correct training and support there for the supervisor, and the guys on that site would have had the right safety equipment to be doing their jobs safely. And Michael, he would still be alive today.
If we look at the electricity safety compliance regulations and guidelines, we look at two main areas. One is HSG 85, which is to do with electricity at work, safe working practices, and probably one that everybody has probably heard of, which is obviously GS 38 when it comes to manufacturing and it comes to test equipment. So I'll briefly go through the two of them. So HSG 85. It's about the safe isolation, it's about the steps we take to make sure and ensure that people are working safely, and to make sure that everybody is obviously following a safe working practices. So where possible, work dead. You don't want to work on a live equipment. And you can see by the pictorial, there are 6 steps to safe isolation. One of the ones that we always mention when we do toolbox talks face to face, and during these times it's a lot more difficult to do that, but the first step is to inform the client or the person's building you're working in that you're going to turn off some circuits, that you're going to isolate them and you're going to work on them, so at least they're aware that if they see a padlock on a fuse board or something being locked off, they will always think of the fact you've informed them about the work that you're going to do. So make sure it's isolated, then you lock it off, you label it with a warning tag and prove dead. And you can see by the pictorial, it's about making sure that before you prove dead, you prove your test equipment works with a means of a proving unit and your voltage indicator. Then you go to the circuit, you then put your voltage indicator across the circuit, whether it be single phase between live and neutral and live and earth. If it's 3 phase, it's between phase 1 and 2, phase 1 and 3, phase 2 and 3, and then do the same between the neutrals and then down to earth. And as long as you're not getting any indication, you've proven it's dead, and you know there is no energy to do with that circuit. Once you've done that, you then need to go back and prove your voltage indicator is still working. Nothing's happened to it in the time when you proved it the first time to when you've gone to work on the electrical circuit. This is where the training comes into it, and obviously as we move forward now, the training and the traceability. Most voltage indicators and proving units now have got serial numbers on them, so you can use them to tag it down as an asset, and you can manage that asset to who is responsible for it. You shouldn't share any of your test equipment, because there'll be instances where you want to prove dead and lock off a circuit when somebody else has already got your proving unit if you've loaned it out. So everybody should have their own individual equipment. And also now you can now get a C&G accredited course for single phase and three phase isolation. As I said in the beginning, I served my time on the 14th edition and we didn't have safe isolation. It was a piece of PVC tape and something written onto it, you know, along the lines of do not switch on. But obviously things have moved on, and that was 30 years ago. Now when you do your apprenticeship and you're going through your time, there is very little time spent doing safe isolation. It's covered within modules, but it's only half a day or a day. Obviously do with City and Guilds, they've come up with these courses, and you can get them available from the NIC, from NAPIT, from C&G, from some other training centres that allow you, as a, shall I say, an elder sort of person who trained a number of years ago to be an electrician, allows you now to have that certified documentation to say you've done a course, you've proven your capability, that you can carry out the procedures to do with safe isolation. And obviously using the right equipment to do with GS38 is obviously one of the most important things. The key changes in GS38, I just want to cover them briefly. As a manufacturer, Martindale have to manage and obviously manufacture our equipment when it comes to voltage indicators to BSEN 61243-3. Now that's a standard that probably many of you don't know, because it's not related to a type of test equipment that you're using in a standard you're using to, but as a manufacturer. And what this means is the changes to that standard has obviously removed the use of fuses with inside a 2-pole voltage indicator. You cannot allow the brightness of a lamp to determine the voltage rating that you used to have in some of the voltage indicators, and the amount of current allowed to be drawn from a voltage indicator has to be below 3.5 milliamps. So those are some of the key changes. More emphasis is being put onto the fact you need to use a proving unit rather than a known live source, because potentially a known live source could take you away from the area that you're working in. And it's making sure you have got the right equipment to carry out the safe isolation procedure and do it correctly. Again, as I mentioned before, inspection of test equipment. You have to make sure that the equipment you've got is not damaged in any way, and if it is, it shouldn't be used because it's not trustworthy. And this is where GS38 and BSEN 61010 comes into it, which is where we're more affair with what GS38 means. Selecting the right test equipment. A lot of people will say, I've got a multimeter, I've got a non-contact voltage indicator or a volt stick, and I've been happily using that on those types of products for quite a long time. But it is clear, clean and simple. You can see the use of multimeters and non-contact voltage indicators for proving dead and not allowed to be used and should not be used. A dedicated voltage indicator, 2-pole voltage indicator, should be used. Martindale make the ones where there are no batteries inside of it. It needs a live voltage to make it work, and they all start to indicate from 50 volts and above. And that way, if it doesn't light up and you are connected to the circuit correctly, hence why the training comes into it, you'll either get a clear indication of a live voltage present or not. And yes, in times we do get asked, I've never made a mistake yet using a multimeter. It's not about you've never made a mistake, it's what happens the one time you get complacent and you don't do what you've normally done in the past. With obviously dedicated voltage indicators, you have no choice. You cannot make mistakes. You put it onto the circuit, you check whether the circuit's live or dead. You can work safely if the circuit has been proven to be dead. Non-contact voltage indicators, yes, you can use them in certain instances for proving live, for tracing a live circuit, but never for proving dead. And lock-off kits and about making sure that you can isolate a circuit. We have got a comprehensive range of locking off devices, and if anybody was to have an accident, you have no excuse. The HSE would not accept, oh, I didn't have an MCB locking off device or in the bag that fitted the breaker because you could isolate the board. There is no excuse. You can keep going as far back as you can down the line on that circuit where it's being fed from a sub board, a main board, unless it's in a critical area that it cannot switch off the supply. For example, in a hospital, you've got somebody who's on a life support machine. You can't turn that off if that's attached to a different circuit. I'm using that as a just as an example. That would never happen, but you can see where I'm coming from, is that if you can turn something off, if you can't manage to isolate it at the actual point of connection, you go back to the breaker of the board, you go back to the main switch of that board. If that's being fed then from another board, you go back to the first line of where that breaker is being fed from. So you've got no excuse, and the HSE will not accept any excuse that you haven't been able to lock and isolate something. So what we've done is we put together at Martindale some kits. So you're, as I said before, you're matching the voltage indicator with the proving unit. You have about 3 different types of output voltage on a proving unit, going from 240, 440 volts or 690 volts, and it's making sure that you fully test that your voltage indicator of what that can measure. Safe and simple, the switches, there's no batteries, there's nothing can go wrong with it as long as you are connected to the circuit correctly. It's got the GS38 tips enclosed, so you're obviously fully compliant with the amount of exposed metalwork that GS38 allows you to do under BSE N61010. It's got a Cat 4 safety rating. Safety categories we'll cover in another webinar later that we'll be doing, but a Cat 4 safety rating means it allows you to work on any circuit anywhere on the installation where it's low voltage, so below 1000 volts. We've also put it together with a carrying case, and we have done this now for about 10-15 years now, but keeping the proving unit and the voltage indicator together in one kit allows everybody to have obviously the means of proving dead of a circuit together in one area. So you're not leaving your proving unit in a van and your voltage indicators in your tool bag, so therefore you think, I know it was working, obviously the last time I used it, I have no need to use a proving unit. It's keeping everything together so that if anything does happen, HSE, the legislation covers you. I've got my proving unit, I've got my voltage indicator. The proving units come with battery indicators, so you can now tell whether you've got low batteries or not. So there's lots of things we've put together, making sure and allowing you to work safely and have the right equipment to be able to carry out the work that you've been employed to do in a safe working environment. If you go onto our YouTube channel, we've got a couple of YouTube videos which last about 3.5-4 minutes. If you want to take note of the web addresses, we will send them out in a link in an email at the end of this session, but at least it gives you that video content of that you can see somebody working on safe isolation and showing you a video of how to carry it out. Thank you for watching today. If you have any questions, you can contact us using the chat option on the webinar or on our website. Alternatively, you can email me directly. Thank you.